All right. So now that we finished Australopithecus afarensis in part one, we are ready to move on to the next major species, which is Kinesianthropus platyops. Now, as you can tell from the name, it's technically in a different genus, Kinesianthropus, instead of Australopithecus, but I'll explain why I'm talking about it here. One of the reasons I'm talking about it here is because it lived between 3.2 and 3.5 million years ago, which is about the same time that Australopithecus afarensis was about. Remember, Australopithecus afarensis appeared around 4 million years ago, died out around 3 million years ago. Kinesianthropus platyops is right in the middle there. It appears around 3.5 million years ago, dies around 2.8 million years ago. It's called Kinesianthropus because it belongs to a new genus based off of its relatively flat face. So we've been talking before about how the Australopithecines were still prognathic. They still had that facial prognatism. Kinesianthropus's face is a lot flatter. It's not as flat as ours, because ours is like perfectly flat, but it's much flatter than we were seeing in the Australopithecines. And some people have argued that that must represent a different evolutionary strategy, that it was occupying some different adaptive zone for whatever reason, which justifies its own genus. Now, the problem with all of this is, and the reason I'm talking about it here with the Australopithecines, is that like we saw with Sahelanthropus chadensis, Kinesianthropus platyops has a crushed skull. So I'm going to go back for the slide for a minute. You can see it's really crushed and in all different pieces. So like we saw with Sahelanthropus, this guy also had to be reconstructed, and so that creates a lot of debates. If you reconstruct the face in one way, it looks really, really flat, which makes it very different. But if you use a different computer algorithm, if you use a different type of reconstruction and it just pows out a little bit, all of a sudden, the Kinesianthropus skull looks really prognathic if you just reconstruct it a little differently. So some people have argued that the flat face reconstruction is wrong, it's incorrect, that instead, Kinesianthropus's face was much more prognathic than that. And so actually, this specimen actually belongs in the genus Australopithecus, which would make it Australopithecus platyops. Other people have argued that if you reconstructed a third way, it looks a lot like Australopithecus afarensis, and so maybe this specimen isn't a new species at all, but really is just a member of Australopithecus afarensis, since it overlaps with the timeline that we know that afarensis was running around East Africa. So I'm talking about it here because there is a chance that there is a flat face new genus running around, 3.2, 3.5 million years ago. There might not be, but it is up for debate. And that's the thing to know about human evolution, is that we are working with very limited evidence. We're working with a very spotty evolutionary record. And so we have to remember that we don't have as much data as we would like. And so we're making vast, theories and conclusions off of the limited data that we have. It's the best that we have. We're doing the best that we can, but that's why some of these debates continue to exist and persist. Now, if you do argue that Kinesianthropus platyops is a different genus and is an actual species, and it did have that flat face, then what happened was it was likely a cladistic event at Australopithecus afarensis. So for some reason, a small population of afarensis branched off, got reproductively isolated, became a new species. Kinesianthropus is its own genus. We know this happens because we have seen it. We're going to see it with Paranthropus in the next part of this module. So it's not so stupid to think that it could happen here. Now, if this is real and Kinesianthropus really does have this really flat face, then it's not outside the realm of possibility. Then Kinesianthropus is then maybe the ancestor to Homo, because in Homo, we're also going to see it getting flatter and flatter faces. Again, it really depends on the fact if Kinesianthropus platyops is a real genus and a real species, or if the reconstruction of the skull is just wrong. It really is up for a lot of debate. But if you want a little more look at it, it does have a small brain. It does have a little bit of a projecting face. Again, not fully prognathic, but it is still a little projecting. It does still have those primitive ape-like molars that we've been seeing. The only real derived trait would be that flat face. It does have a taller cheek region. It does have perhaps maybe a little bit larger of a brain, although the jury's still out on that because that also depends on how you reconstruct it, would depend on its brain size. So just a lot going on here, a lot of unknowns. If it is real, it could be it's a real cool thing in human evolution. If it's not real, then this is all bunk and it's all for nothing. But let's move on to another species that we do know exists, and that's Australopithecus africanus. Now, Africanus is important for a couple of reasons. One reason that Africanus is important is because this is the first fossil hominin that was ever discovered in Africa. Obviously, not the earliest in evolution terms, but in terms of the history of science and the history of doing studies of human evolution, it was the first. We found the first Africanus skull in 1924. It was found by Raymond Dart. And this was important because this was the first time we had a fossil specimen that was small-brained but bipedal. So this was the first time that we were like, wow, maybe this thing, our brain, is not what makes us human. Maybe it's our feet. So this was really cool. It was really important. Africanus is also the first hominin species that we know of that is in South Africa. So Africanus is a little younger than Afarensis. It dates to about 3 million years ago, down to about 2 million years ago. So again, lives for about 1 million years. But it's the first one that we've got of this Southern African clade that I talked about in part 1 of this lecture. Every other species we've looked up at into this point was East African. So this is really, really cool. In Australopithecus africanus, we do have over 200 specimens from this species. So it's a pretty sizable fossil collection for, again, all things being relative. And we mostly find them in caves just because fossil preservation is really particularly strong in caves because of the water dripping and the minerals and things like that. It really helps for fossilization and preservation. Now, we used to think that Africanus was the direct ancestor to Homo. We don't necessarily think that anymore, but maybe we still do. Like I don't know. I've heard people who study this. I study like European fossils. I'm not really an expert in the African debate. I'm more interested in Neanderthals and very early modern humans in Europe that we'll get to toward the end of this course. But the thing is that we were like, yeah, this is the direct ancestor to Homo. And then we were like, no, it's not. And then we're like, maybe it is, but maybe it's not. We do think that it gives rise to the genus Paranthropus that we'll talk about later in this module. But it doesn't seem to be the direct ancestor to Homo anymore. Now, what does it look like? We do know that it is more derived than Australopithecus afarensis, which makes sense because it's living about 1 million years, after. So Australopithecus afarensis, 3 to 4 million years ago, Africanus, 2 to 3 million years ago. So it makes more sense that it would be more derived and closer to what we're looking for, which are the traits that make us, like Homo sapiens. In general, it looks more human than Australopithecus afarensis, particularly in its ability to be a biped. So while it still has some primitive traits that we're seeing, so its arms are still longer than its legs, it still has slightly curved hand and finger bones, it still has those upward oriented shoulder joints. In general, its pelvis, its limbs, it's the shape of its femur, all of that stuff that we started seeing develop in Afarensis is becoming more developed here in Africanus. Now, we're also seeing very, very marginal brain expansion. It's still, in general, is the primitive trait of having a small brain, but its cranial capacity is slightly larger at 450 cc's. This gives it an encephalization quotient, which means brain size in comparison to body size of about a 2.7, which is a little bit on the larger side for the Australopithecines. Ours is anywhere between a 6 and like a 7.5. So very, very small compared to our encephalization quotient, but it's getting bigger gradually small little changes here. And the major areas that we're seeing with the most expansion are the cerebral cortex and Broca's area. Broca's area, which is involved in language use, so might suggest some early, very primitive language use here, but the jury's still out on that. Now that we're seeing brain expansion, where are we seeing that brain expansion? Well, what we're starting to see here is just the littlest, tiniest formation of a forehead. So if you look down at the photos, Australopithecus afarensis definitely has that, it's the eye orbit and then a slope back. And you see with Africanus that it's just a little up movement. It's just a little bit of a forehead. As modern humans, we have very ginormous foreheads because we need somewhere for all of that brain to be. Africanus is getting that there. It's also losing a sagittal crest, which is also going to allow for more brain expansion toward the top of the head. But otherwise, its face is still very prognathic. That's still very primitive. But another derived trait that we're finding with Africanus is that we're starting to lose that U-shaped dental arcade. We're starting to see that more parabolic dental arcade that is very reminiscent of us, modern Homo sapiens. We're also starting to see that Africanus is starting to evolve smaller teeth. But even though its teeth are smaller, it has teeth that are made for a very tough diet, which might be why they're ancestral to Paranthropus. But we'll get into all of that stuff. Keep that in the back of your mind for later in this module. Another derived trait that we're starting to see pop up here is that they are less sexually dimorphic than Australopithecus afarensis. They're more sexually dimorphic than us, but less so than afarensis. So again, small, gradual evolution of some of these traits. The males are about 4'5" and 90 pounds. The females are about 3'9" and 67 pounds. So we're starting to see a reduction in the difference here between males and females. But again, they're still very small statured and still very small in body shape and size overall. All right. Now that we've finished Africanus, we've reached the point where we've left the Miocene now, or the Pliocene, sorry. So we moved to the Miocene with the apes. For all of the other parts of this lecture, we've been in the Pliocene, and we are now ready to leave the Pliocene and enter into a new epoch that we call the Pleistocene epoch. And the Pleistocene is going to start here around 2.6 billion years ago. So Africanus kind of lives through that divide. And it's going to go down to about 11.7 thousand years ago. The Pleistocene ends pretty much when the ice ages end and when we start farming as humans. And the Pleistocene is usually kind of colloquially, or why did I just butcher that word? But you know what I mean. Referred to as the Ice Age. It's characterized by global cooling, lots of glaciers, dropping sea levels because all of the water is trapped up in ice. There are still going to be warm periods, even in a glacial period like this. But the Pleistocene really starts because now we're like the global cooling and global drying out has kind of reached its peak. It's reached its zenith. And that zenith here is the Pleistocene and the Ice Age. And during this period, we have other species start to pop up. So one of these species that's from East Africa, is from Ethiopia, is Australopithecus gari. And this dates to 2.5 million years ago. We don't have a lot of bones from it. We have parts of its crania. So you can see in the photo the bones that we actually have. We have a little bit of its upper jaw. We do have some limb bones that were found nearby it. But they're just far enough away that we can't know for sure if those limb bones are associated with these skull bones or not. So we can't say that they are. We can't say that they're not. They kind of exist in this nebulous place where we don't say that they are for sure, but sometimes when we talk about gari, if we want to know about things like bipedalism and things like that, we will sometimes refer to those limb bones. But just know that we are not 100% sure if those limb bones actually are part of Australopithecus gari or not. Now, Australopithecus gari is likely a direct descendant of Australopithecus afarensis, and actually might be a chronospecies of afarensis. The reason is that while it's a little bit more derived than afarensis, it actually shares a lot of traits with Australopithecus afarensis. It doesn't share a lot of traits with like Africanus and the shit that's going down in South Africa. So it might just be that afarensis just got enough derived traits that it starts to look really, really different. And now we call it Australopithecus gari, but without any like branching or speciation event occurring. So this might be one of those few examples of Pokemon evolution where Charmander evolves into Charmeleon, where Australopithecus afarensis is evolving directly into gari. So I know the biology majors in the room who are like evolutionary specialists are like freaking out because this is not how evolution is supposed to work. That means they're the same species, but in evolutionary terms, we're calling them two different species. And some researchers believe that this species is the one that's most ancestral to Homo. And we'll talk about why in just a second. Now, it still has some primitive traits. So it still has long ape-like arms if those limb bones are associated with the crania. Again, that's a big if. But it does have a small brain. It's relatively the same size brain that Australopithecus afarensis had. However, it does have some more derived characteristics. One of those big ones is that its leg bones, if the limb bones are associated with the skull, if they are, then those lower limb bones are longer and more human-like than afarensis did, which might be why it might be ancestral to Homo. It also has just more robust craniofacial dental features that are more derived than what we were seeing with afarensis. Now, there are also stone tools found directly at the site with Australopithecus gari. And we also have antelope bones that were also found at that same site that have cut marks on them that were made by stone tools of somebody in the past cutting and butchering this antelope. And these both date to 2.5 million years old. So this means a couple of things. One, this isn't like changing the game that the Lamequian was, because the gari tools date to about the same time we already knew that stone tools existed in Olduvai Gorge, 2.6 million years ago. So we already knew stone tools dated to this time period. But those tools that I'm talking about, the 2.6 million year old tools in Ethiopia at Gona, those are associated with the genus Homo, which we'll talk about in the next module. These are associated with an Australopithecus species, which means that we now have a more evidence, a second round of evidence of Australopithecine making stone tools, because the Lamequian were made by Australopithecus afarensis. And if gari is a direct descendant of afarensis, then that means this whole line of afarensis and gari are making stone tools, which means that stone tool making is not just our genus, but another genus as well. And when we get to the next module, you'll see why that is going to become a big debate when it comes to naming species and phylogeny. So that's gari. Another species that we more recently found just in 2008 from South Africa is Australopithecus sediba, and this dates to about 2 million years ago. Now, it has a lot of traits that are similar to Africanus. Makes sense because Africanus was also in South Africa, so it's probably descended from Africanus. But another really interesting thing is that it also shares a lot of traits with early Homo. So it might also be a link between the genus Australopithecus and our genus, the genus Homo. Right? If this is true, then any of the stuff about afarensis or gari being ancestral to Homo has to be thrown away. And we instead have to start maybe thinking that it's the southern clade, the Africanus sediba clade, that's actually ancestral to us. Now, the one issue with this, though, is that it actually has more in common with later species of Homo and doesn't really have that much in common with early species of Homo. Now, that's a little weird because that's not how evolution works. So that doesn't make sense. It also doesn't make sense because they're in South Africa. The origins of the genus Homo are in East Africa, so that doesn't make a whole lot of sense either. But this whole thing's a mess. And the whole thing to know about human evolution is that it's messy. And that's why I love it. I love it because it is messy. Right. The other thing, too, is that it's only 100,000 years younger than Africanus, and it's at the same time as the earliest Homo species. So is that enough time for like all of this evolution to be happening? Maybe, but also it seems unlikely. So that's a mess. What will also complicate this story is that maybe the early members of Homo habilis, that we often think of as being the earliest member of Homo, might not even be Homo. It might be Australopithecus, which means that again might suggest that Africanus sediba moves into later Homo, which opens up this window. I know this is all messy. It's all complicated. It'll start to become a little clearer as we move through the course, but just know that this is all a mess and we don't actually have a good grasp on this because different lines of evidence all contradict one another. Now, as I said, physically, Australopithecus sediba is a mix between Africanus and the members of the genus Homo. It still has that primitive small brain. While it's not expanding in size, Sediba's brain does show some evidence of reorganization. And we know this because you essentially take the skull and the cranium and you essentially like make an endocast. So you fill it and then you like pop out the cast and now get an indication of what the brain looked like. It's kind of like when you're at the dentist as a kid and they shoved that thing up into your mouth to get a mold of your mouth and it was like that gross pink stuff and you couldn't breathe. Think about that, but just doing that for the brain. And this brain reorganization makes it look more like Homo. And this is important because intelligence is not just about brain size, but it's also about how your brain is organized. And this shows us that maybe our brain started to be reorganized before it started to actually expand, which would be really cool and really important to our understanding of the evolution of the brain. It has small teeth, which is what we're looking for because Homo has small teeth. It's starting to reduce the robusticity of the face, which is important because we don't have a very robust face. We also have evidence that maybe they're starting to have a protruding nose like we do. The jury's still out on this just because noses don't preserve, but the bones are starting to indicate like they're looking to support the cartilage of a nose. Still relatively arboreal. Remember, the southern clade is arboreal in general. They still have those long arms, those shoulders adapted toward climbing, but their hands are starting to become an intermediary between what is needed to climb and what is needed to make tools. And they might be the stone tool makers for a lot of these stone tools we're finding at South African sites that don't have any associated fossils. So Sediba also might have been a tool maker. Now, what they also are starting to do is they're also starting to make some changes in evolution of the thorax. So we've talked about this a little before, but we have a barrel-shaped thorax, meaning our thorax is pretty straight up and down, while the Australopiths had the conical thorax, meaning that it's pretty small at the top of the thorax, but then it starts to make a triangle and bows out almost like a cone. And you can see that in the most lefternmost photo here, where it's like relatively small at where it meets the neck, and then the like thorax starts to branch out with the ribs and stuff there. We have a barrel-shaped thorax because it makes it easier to walk and run as a biped. It just makes us efficient. It allows us to breathe easier while we're running and walking. It does give us less room for our digestive tract, but that's pretty normal for us as humans because as humans, we don't have a very good digestive tract. That's why like your dog can go outside and just eat like every shitty thing it finds and barely get sick, but you eat one small little thing and you're like throwing up and you have a tummy ache. That's just because our digestive system is really weak. It's an evolutionary trade-off. We dedicate more energy and more of our caloric intake to our brain and less to our digestion. Your dog, your cat puts a lot more energy into digesting hard see evolutionarily here, even though we weren't using fire and we weren't cooking yet, that our bodies are starting to value bipedalism and the advantages of bipedalism more than the advantages of being able to digest whatever shit you want to eat. Now, the point of everything that I'm saying is that Australopithecus sediba is kind of in the middle. It's kind of an inner mediary between the Australopithecus thorax and the Homo thorax. And their environment, their way of life is pretty much what we've been seeing here. So to summarize the genus Australopithecus, since I know this was a long lecture over 2 parts, is that they have a small brain. We don't see much change there. They have large chewing muscles, not as massive as we're going to see in Paranthropus, but much larger than us. And that's because they probably weren't processing and cooking their food. For the most part, they still have those projecting faces, and they don't have much of a forehead. Africanus and Sediba have a small forehead, but for the most part, we don't see foreheads because they don't have big brains. They're not very smart. They still have those very small encephalization quotient. As Homo sapiens, ours is anywhere between a 6 and a 7.5. Chimpanzees are at 2. The Australopithecines are here about 2.5. So marginal brain expansion, but not very much. They are the biggest thing that we saw with the over the Australopithecus with these evolved traits is that they are becoming more efficient bipeds. Their pelvic morphology, their lower limb is starting to look more human-like and less chimp-like. They are developing that valgus knee. Australopithecus gari might have been evolving more modern lower limb proportions if those limb bones actually are associated with the skull bones. They probably aren't walking exactly the same as us because they still have a lot of that evolutionary baggage, a lot of those physical features that were adapted to living and swinging in the trees. Remember, evolution doesn't strive for perfection. It just strives for good enough. And at this point, their bipedalism was good enough. But there probably was a lot of variation in terms of bipedalism. Remember, the East African species are going to be better bipeds. The South African species are going to be less good bipeds. But bipedalism and the kind of refinement here is really the major evolutionary thing that we're seeing across the Australopithecines as a genus, as well as, remember, the advent of stone tool making. But otherwise, they're still adapted to living in the trees in a lot of ways. They're still small-bodied individuals. They still have high levels of sexual dimorphism, some species less than others. But in general, we're not seeing a huge leap in anything here except bipedalism. So all of the red species are the Australopithecines that we talked about here. Some of them are the Paranthropines, like the P. robustus, P. boisei, P. aethiopicus, that we'll talk about in the next section of this module. And then in the next module, we're going to pop up on over and start talking about the blue species, our genus Homo. So here's a little evolutionary map. Somewhere between Auroran and Ardipithecus, we get Anamensis, who's the origin of the Australopithecines. You know, we get Afarensis and Gari, the major East African clade, Africanus, which is the South African clade. Africanus gives rise to genus Paranthropus. We'll talk about in a minute. At some point in all of this, our genus arises, and we'll get to that in the next module. I know that was a lot, so if you do have any questions, please let me know. Otherwise, yeah, we'll keep talking here as we move on. Sorry, stop recording.